A sealed flask with a capacity. This is another interesting problem. A sealed flask with a capacity 1 decimeter cube contains 5 gram of ethane. The flask is so weak that it will burst if the pressure exceeds 1 megapascal. At what temperature will the pressure of the gas reach the bursting pressure? Look, this is a very interesting problem. I am having a sealed flask and the volume of the flask is 1 decimeter cube, and I have filled this flask with 5 gram of ethane, and when I raise the temperature, the pressure will also rise. So when I go on raising the temperature, pressure will go on increasing, and the sealed flask can withstand a pressure below 1 megapascal. So certainly at a particular temperature, the pressure will reach this limit of 1 megapascal, and at that temperature, the flask will burst. And we are asked to calculate that bursting temperature. So first, what is given is the weight of ethane. So from the weight of ethane, you have to calculate the number of moles of ethane. So number of moles of ethane can be calculated by understanding this for one particular concept of mole. See, 1 gram molecular weight, that is, suppose if the molecular weight is 30, molecular weight of ethane is 30 gram of ethane will contain 1 mole of ethane. See, hydrogen atomic weight is 1.008, which means that if you have 1.008 gram of hydrogen atom, that will contain Avogadro number of hydrogen atom, which is 1 mole of a hydrogen atom. So if you want to find out the number of moles of a particular substance, you have to divide the weight taken by the molecular weight. Or you can say number of moles into molecular weight will give you the actual weight of the substance taken. So that is what is done in the first step. Number of moles of ethane is equal to 5, the weight taken, divided by 30, the molecular weight. So this is the number of moles. Actually, I have not done the simplification because as a fraction itself, I can substitute in the problem and I can do all the calculations at once. So what is the bursting pressure? It is 1 into 10 power 6 Pascal, because we are going to substitute in terms of Pascal, and what is given in the problem is megapascal. Mega means 10 power 6. So volume of the flask is 1 decimeter cube. I have already told you 1000 decimeter cube is equal to 1 liter. And also I have to convert this into meter cube. So 1 into 10 power minus 3 meter cube is 1 decimeter cube. Now the simple substitution in the ideal gas equation, PV is equal to nRT. What is asked is the temperature. So the temperature is equal to, I keep the temperature in the numerator and I bring nR here. So what I get is PV by nR. So PV by nR, I am going to substitute. What is pressure? 1 into 10 power 6 Pascal. Actually, the minus is wrongly written. It is 1 into 10 power 6 Pascal into 1 into 10 power minus 3 meter cube, which is the volume, divided by the number of moles N. N is 5 by 30 mole into 8.314 joule per Kelvin per mole. So when you do all these calculations, see, the Pascal is joule per meter cube. So the joule per meter cube, that per meter cube and this meter cube will get cancelled. So the joule is here and another joule is here, that will also get cancelled. And here is a mole and here is a per mole, that will also get cancelled. Kelvin is in the denominator with a -1 power, therefore this will become the Kelvin. So when you do all these numerical problems, numerical calculations, you are getting 721.67 Kelvin. So if you subtract 273, you are getting 448.67 degrees centigrade. Therefore, when you raise the temperature to a level of 448.67 degrees centigrade, the system will reach a pressure of 1 megapascal. At that pressure, the container will burst. So that is the thing.